Welcome to the Rare Earth Exchanges podcast, where power, politics, and the world's most coveted materials collide. Rare earth elements power the backbone of tomorrow's most critical technologies. With China dominating global production, the US and its allies must align strategically to ensure a stable future. This urgency prompted tech entrepreneurs Daniel O'Connor and Dustin Olson to launch Rare Earth Exchanges, a news and insight platform built to equip stakeholders and decision makers with the tools and intelligence needed to reduce dependency and build prosperous resilience. Let's get into it.
Hi, everyone. Welcome back to the Rare Earth Exchanges podcast. I'm Dustin, your host, joined by my co-host, Daniel. And today's guest is Fred White, the co-founder and chief commercial officer at DEScycle. And DEScycle is a metal recovery company in the e-waste space. Fred, welcome to the show. How are you doing?
Thank you, Dustin. Yeah, great to be here.
Awesome. Fred, let's dive into your background. It looks like you've been in the industry for a long time and you've done a variety of things to even arrive at DEScycles. Tell us about that.
Yeah, absolutely. So geologist by background. So first job for me was in exploration in Zambia on a big copper project for a company called First Quantum Minerals. Left exploration and went more into the finance side in London, where then I financed project building, trade finance, commodity traders. And so I've kind of done almost every piece of the metals flow. And now I've been recycling. So it's almost a full circle of getting metal out of the ground originally to now recycling it and recovering it.
That's great. Circle of life. See the end to end. That's really awesome. Now let's talk about DECycle. Well, how long has it been around, and what was the need? What was the challenge that you guys saw that made it come to be? What started it?
So we came across a completely new class of chemistry that was being developed at the University of Leicester here in the UK. It's a ionic chemistry, so liquid salts, and the chemistry itself is called Deep Eutectic Solvent, or DES for short, which gives you a bit of a clue where the name DEScycle came from. So the whole company started by a complete accident. So the scientists at the University of Leicester discovered by accident that DES could dissolve gold. And what actually happened there was the paleontology department were covering fossils in gold, and they were then having a really tough time removing gold from the fossils, which is good for imaging the fossils, with standard chemistries. So your regular acids and things like aqua regia that they were using were really quite damaging the fossils underneath. So they asked the chemistry department, who had this new DES chemistry they were playing around with, hey, do you reckon this DES can dissolve gold? Turns out it did a really good job at dissolving gold. And they realized maybe this has got applications in metallurgy. And so that's when we first met the chemists and the scientists at the university, saying, we think this has got applications in metallurgy. And then what we did as a company was founded DEScycle around 7 years ago now, to look at commercializing this chemistry and applying it in the field of metallurgy. Our initial investment thesis was, okay, well, it's clearly dissolves gold, so let's use it as a cyanide replacement technology for the mining industry. And in the first few years of DEScycle's life, we did a lot of early stage proof of concept work on not just gold, but we brought in some of the major mining companies to work with us, and we worked on PGMs, we worked on copper sulfides, nickel laterites, basically a lot of the full suite of the periodic table, rare earths, we worked on. So what we essentially did for the first few years of DEScycle's life was prove the breadth of the technology without then advancing it materially forward. So we then had a rethink about 2021 and selected our key feedstock to move forward with.
That's a great origin story. And sounds like a great opportunity to support multiple commodities with e-waste. So do you guys have a specialty? Or are you saying, hey, we support the entire periodic table? Or are you saying just rare earths, or where do you guys feel like your specialty is?
Yeah, so what we've developed is really a metals recovery platform, and it can take multi-feedstock and recover multi-elements, multi-metals from any feedstock. What we're doing is optimizing that technology for particular feedstocks to launch. So we've selected electronic waste, e-waste or e-scrap, or WEEE as it's known here in Europe, as our primary feedstock. And the reason we did that is it's incredibly valuable. Yeah, this stuff has got grams a ton gold to 200 grams a ton gold, lots of copper, lots of nickel, lots of silver, palladium, tin, you name it, it's tinny waste in some forms. With such a rich polymetallic mix of metals is an ideal, let's say, starting feedstock for DEScycle from both a commercial and technical standpoint.
So at a high level, basically, you identify the metals that you can extract out of the out of the e-waste, and from there you refine or you process it, and then you sell it in a more refined state to buyers, right? Is that sort of the business model?
Exactly that. So think of DEScycle as a midstream metals recovery company. We will take in feedstocks like electronic waste and then recover and produce high purity forms of whether that's copper, gold, rare earth, tin, whatever the target metals are, we're going after in that given feedstock.
So if we look just at the market, like the market in Europe and United States, like how pervasive is this process? Like, of the feedstock that could be derived out of the waste in those two markets, what percentage today is being done through this process? Not just your company, but the whole market.
Yeah. So this is a brand new technology. So no one before has commercialized this field of chemistry, this class of technology, which we're referring to as an ionometallurgy rather than hydrometallurgy technology. We are the world leaders and world first in processing this. But there's a deeper question here, and it's quite interesting to pick up on actually, is, what percentage of the waste we're actually producing is ultimately recycled?
That's right.
On a basis, it's only 20%. So
Okay.
by 2030, we'll be producing $130 billion of recoverable metals in electronic waste. Yet we're still only recovering 20% of that $130 billion. So it creates a really strange paradox where on one hand, you have governments and industries concerned about shortages of critical metals. But on the other hand, we're throwing away vast quantities of those same metals in legacy products every year. So it begs the question, what's the problem?
Well, I mean, I think that paradox is key, right? And that comes down to, culture, systems, processes. So what do you see today? Let's just take your technology out of it for a minute, because there's other ways to get this stuff out. Yours may be better, right? But the idea here is, what's in the way of, what's the biggest impediment that you see that keeps it at 20% versus 50% or 70%?
Yeah. So we don't see the problem of metals availability. We believe the problem is infrastructure. So today, metals are recovered from electronic waste and a whole load of other secondary feedstocks through the smelting process. And as you will both well know, smelting is a massively expensive, globally centralized process, which is slow to scale, incredibly expensive to build. So we have this technology and business model and structure in the recycling market that is almost offshoring and globally centralizing metals recycling and metals recovery. What's happened in that, you have the smelters, although they're all competing against each other, there's a relatively low number of them, which gives them a lot of buying power in the market. And what we're seeing is the guys who are doing the physical collection of the things like electronic waste, so picking up your laptops, your televisions, whatever it might be, small domestic appliances from your homes, are getting a pretty raw deal in terms of the metal value for the components they recover. So that in itself is not incentivizing a lot more collection that could be done. And there are multiple different challenges, like you said, including culture that go into collection. But we believe if we can unlock domestic metals recovery and provide a business model that incentivizes more collection, we can help drive those recovery rates or global collection rates up from just 20% and start them going upwards.
Okay, so Fred, I think there is a small number of smelting companies that are controlling the market by underpaying for the waste, but controlling the process, and that's not efficient. So you don't have an efficient outcome. they have control or a feeling of control, but you're at 20%. So the current, because they're not paying that much for the scrap waste, right? So we've interviewed people in India. There's whole companies forming in India where not only are they doing what you're doing, but they've created e-commerce sites where people across India can sell. They've created a market where you can sell their waste through these e-commerce platforms. So they're trying to incentivize people in India to, hey, you sell it to us. Don't go to those smelters. Come to us through this e-commerce platform, and we'll pay you more for it. Okay, so we definitely, do you understand what I'm saying?
Yeah, absolutely. I've come across a few of those e-commerce platforms, and there's been a couple that have been attempted to be launched here in Europe as well.
That's right. They're trying to expand into Europe. Some of the Indians. So now, so what comes down to your approach is this DES, right? Which is a do you want to break it down for lay people a little bit? Try to simplify it. We're trying to democratize all of this information, and then we can get into the rare earth and critical mineral specific topic. But what is DES, and why is it better than the predecessor, according to your company?
Exactly. So DES are essentially salty liquids. And what we're doing with them is using these liquid salts, which are liquids at low temperature, to selectively separate metals. Now, DES is not just one chemistry, it's a whole class of chemistry. So imagine someone has just discovered acids as a class of chemistry for the very first time. There are millions of different possible acid formulations. That's what we have with DES chemistry. So there are millions of different possible DES chemistries that we can use and tailor to be selective for different metals in metal recovery. And really what we're doing through the process is we start with a polymetallic or a mixed metal feedstock going in the front, and then we can be selective on what we dissolve by tweaking the chemistry and the conditions. Right. And we can be selective on what we recover from solution. So by that selective dissolving step and selective recovery steps, then we can take what is a mixed metal input and make high purity metal outputs, which is separated from one another.
Output. Can you, is there specific DES formulations that you can talk about that are used? Let's just say for rare earths. Okay, let's just take heavy rare earth metals. Is there a specific formulation, DES formulation for that?
Yeah, so there's, I wouldn't say there's exactly one known recipe that works on one known metal. What we've done at DEScycle is take the base of DES chemistry, which is usually a 2-component system. So you're mixing things in that 2-component system, which are things like urea, a common fertilizer. We use something called choline chloride, which is vitamin B. Its main use is in the chicken feed industry. We can things like ethylene glycol, for example, which is antifreeze. So we've got fertilizer, antifreeze, and vitamin B, and inputs like that. And they form the base of the DES chemistry. And just to give you an explanation of what's going on there, it's a little bit more special than that. So when you mix, let's take antifreeze and vitamin B together in the right ratios, a special chemical reaction happens. And what happens is you have something called hydrogen bond donation, but I won't get too into the chemistry today. But essentially by mixing these 2 inputs together, this special chemical reaction happens and the melting point of the system drops. So the melting point, or the eutectic point in scientific terms, significantly drops. So we can mix 2 solids together and without adding any heat, a liquid forms. And this liquid is very electroconductive and very good at dissolving metals and holding metals in solution. So that is the basic concept of what a DES is.
And okay, and that's helpful. I can conceptually pick up on that. The concept of technology readiness level. You understand?
Yeah.
Where is this? Where is it at in that process? Is it pilot? Is it commercial? Is it like what's the status of this novel breakthrough?
Yeah, so we're rapidly approaching on TRL7, building a demonstration facility right now in the UK. It is well under construction, and we should be commissioning the demonstration facility in July of this year. So about 3 months away. In
Okay.
fact, we've ceremony 3 months yesterday.
So that's
Um,
exciting. That's exciting.
Really exciting. Yeah, really
Yeah.
exciting. It's the first time we've really moved it outside of a pilot environment in a lab into the industrial world. And you'll know that, that TRL7 step and onto the industrial world, industrial equipment is a massive step for any company in technology.
So there's a very important question that I have, in terms of, in the rare earth element space, which is, what we kind of focus on, but we also get into the critical minerals, metals, um, solvent extraction. That's what's really used in China and other places, right? Um, how does the efficiency, the selectivities and separation efficiency of DES compare to that?
Yeah, very high, very high.
Okay.
So in terms of selectivities and recovery yields,
Yeah.
in our pilot, which is TRL6, which we ran for 12 months, we averaged over 99% metal recovery rates for the target metals we're going after, and that's
Wow.
an average. So the performance of this chemistry is exceptional, and there's a few other critical differences versus standard solvent extraction and standard hydrometallurgical processes, so acid-based processes, that are really key to understand the true concept and value of DES. So firstly, you use DES chemistry in a different way than you use acids. So when you dissolve metals using acids, your acid is consumed in that process. It gives an electron away to make a metal chloride or whatever it might be. And then after you're done with your metal dissolution step, you then need to dispose of or regenerate your acid, which is expensive, emits CO2, a whole load of things that really add on to your unit economics. With DES, what we're doing is really using DES as the medium of metal dissolution. And what's happening there is metals behave differently in a DES system, so in a salty liquid system, than they do in a water-based system, so an acid system. And we take advantage of that different metal recovery, or sorry, that different metal behavior in the chemistry to treat it in a different way. So what we're doing is we add a couple more components into this DES, something we call an electrocatalyst. And to simplify it as much as possible, think of this like a reverse battery. So we add this reverse battery in to the DES chemistry. And what it's doing is it's stealing electrons from the metal atoms. It turns those metal atoms into metal ions, which are then liquids in the chemistry. This battery becomes fully charged of electrons. And then all we do is we discharge that reverse battery. So we drop all the electrons off. Then what we have is a DES, which is chemically exactly the same, a battery that we've just charged and discharged, and we just loop that back around the system. So nothing is consumed or lost from the chemistry. So we have a very low use of chemistry in this process, which is really helpful for unit economics.
So and that goes to the efficiency question. What about, here's another one for you. I have few more questions, Dustin. I appreciate the kinetics, that reaction speed, throughput compared to or relative to hydrometallurgy. Like what about that type of data point?
Yeah, to be honest, even I was blown away this year from the success of our technical team. So I'll just give a special shout out to our CTO and inventor of the technology, Dr. Rob Harris. So when we started this process in our kind of 2021 RL3, looking at e-waste, we were taking around 24 hours to leach all the metals. We improved that to around 6 hours over the following 2 to 3 years. In 2025, we improved our leaching time for 100% leaching to 15 minutes at low temperatures and ambient pressures. So the leach kinetics are incredibly rapid.
That's good to know. Now here's a significant question for you, Fred. This is important. What, peer review published evidences are available? Like if we wanted to go write about this, and validate it out there, third party, how much literature is out there to support these claims?
Yeah. So to support the company performance, very little is out there in the public domain.
Okay.
But we have actually run an independent techno-economics assessment for
Okay.
our technology ahead of our Series A. So, that's a document that's obviously private. But we use that to bring in Series A investors. Critically, we brought in two major strategic investors in that round. So there's a Mitsubishi Corporation in Japan
Yeah, I
and
think I
Cisco.
remember that. Yeah.
Yes. Yeah. So it's
Yeah.
been a success for us. There are general papers on DES chemistry out there in the wild. What I would say, it's still quite a nascent area of science. So the quality of some of these papers can be up and down.
Right, right. And also, I mean, to your point, it's proprietary, and so you're not really ready to let it out there, and that's fine. What about scale and throughput? Like, let's just get. I mean, right now there's a shortage of heavy rare earth elements. So let's just tie it into this. What this platform focuses on mostly is that. Do you have the ability to pull out the heavy rare earth metals elements from scrap metal?
Yes. So particularly things like magnets, which are concentrated in them, will be able to separate heavy and light rare earths. The trick is then obviously being able to separate the individual elements
That's right.
in
That's
that
not easy.
area. If you guys know, that's not easy. That's like
No.
the 300 solvent extraction process that you mentioned earlier. And what we're doing first is focusing on electronic waste. And the main value metals are there are gold, copper, silver, palladium, tin, bits of nickel. So the rare earths for this first version of the technology are, let's say, a minor focus for the launch and
That's fine. Let's talk gold. Like how much gold can you pull out? Let's just say a ton of e-scrap. How much gold can you pull out?
Yeah. So a ton of e-scrap can contain 200 grams a ton of gold. So if you take a server board, you'll have 200 grams of
200
as a
grams.
Yeah, that's right, Daniel. As a geologist, I was used to working on gold mines where if we had 2 grams a ton of gold, that was a fantastic drill core, and we were able to see, and we're going on. It kind of blew my mind at the start, being like, "Is this right? Is this correct?" So it's this incredibly rich feedstock, and it's one of the reasons why we pursued electronic waste as the kind of launch feedstock for this technology platform that we have, rather than EV batteries and rather than magnets as our first choice. Just because of the raw material value in there, it gives us a lot of flexibility and optionality with the business model.
So let's just take that though. That 200 grams, what would that be worth? Like just like I'm just running a quick experiment in my head. What would the 200 grams worth? Would that be like $15,000 or something like that? What would that be worth?
Yeah, a little more than that. So a ton of, say, server board waste from data centers, that's without all the nice CPUs and GPUs on top, would be worth between $25,000 and $40,000 a ton of raw material value contained within it.
Okay. So the key is the gold wouldn't be enough because 200 grams of gold, is going to be about $15,000. Okay. If you look at gold is about 20. What is gold per troy ounce today? I don't know, but the point is, Fred, that you can get multiple metals out. So you're going to get gold. You're going to get, some of the other ones you mentioned. So when you add up all those different metals that you're pulling out, what's your profit margin in that hypothetical ton?
Yeah. So hypothetical ton, we're making around 35% profit margin.
Okay.
And
right.
just so breakdown numbers. So gold right now per kilo is around about $150,000 a kilo. So we'll be getting around $30,000 of gold value out of that ton of e-waste.
Okay. But again, you're getting other metals too, right? Like you're pulling out.
Correct.
And then you have feedstock, or you have different vaults with different metals that you're accumulating that you can sell at a markup, right? And you're getting it out fast. I mean, theoretically with DES, we still have to see, it in action, but theoretically you're getting this out faster and more profitable.
Exactly that. There's also another step, and this is where it gets quite exciting for a new business model coming into to metals recovery. So right now, when you go to recycle metals, you ultimately send stuff to one of the major smelters. They commingle secondary materials, usually with primary ore, so copper concentrate, if you're e-scrap, for example. and it goes in the big smelter, everything's commingled, and then you'll produce high purity metals. Process works. Whereas what we enable is closed loop manufacturing. So we're looking to work with groups like Cisco, like Mitsubishi, who are both invested in DEScycle, to take metals from their legacy products and then reintroduce them with digital product passports back into their own supply chains. For those companies, they're not just using recycled metals, they'll be using Cisco metals or Mitsubishi metals.
That's right.
Products.
And I'll just stop you right there. We track mainland China extensively, right? And much of this stuff happens in China, but that's exactly what they're doing, Fred. And that's what we need to be doing, right? So I like where you're going with this. You're basically assuming it works. And, again, there's major investors going into, so these are pretty smart people. Basically, you're bringing the ability to do continuous refinement capability, a continuous processing, continuous throughput. So for Cisco or for any of these companies, they can expend waste, comes into the system, DES processes it, you refine it, you give it back to them in a form they can use again for their manufacturing.
Yeah. Exactly that. And the real disruptive thing here, it's not just the chemistry and the technology, it's the infrastructure model. So we do not need to build a 1 million ton, $7 billion dollar capex smelter, right? There's a behemoth smelter being built by Korea Zinc now in Tennessee. I'm sure that's going to be an absolutely amazing facility. We're not going to see those rolled out in, all over the world, let's be honest. What we enable is small scale infrastructure to be deployed. So you do not need your multi-billion dollar capex. You do not need your, hundreds of thousands of tons of secondary materials to put through your smelter. So the fact that this technology can scale down and be deployed at a much smaller scale in a repeatable fashion unlocks these different business models. So, picking on Cisco, I mentioned them again, we can co-locate a DEScycle facility right in the middle of a data center cluster or right on Cisco's campus to then process metals without them ever leaving.
No, I think that's very exciting because you can, your business model, you can license. It's like you can charge an annual subscription. There's other fee costs that you can extract out of the customer for that model, right? It becomes a perpetual. It's like not a virtual refinery, but I see what you're saying. It's a different model. Let's look at some externalities though. Like, are there any toxic output that are different than these other approaches?
In a short word, there's a lot less outputs and a lot less hazardous to deal with than hydromet or pop. So one of the nice things is because we have so low effluent or liquid waste, because we're just pumping up around and around the system, there's relatively few things that come out of it. So right now, our waste products, we produce iron is mostly the waste metal, and we'll have more minor metals in this kind of iron product from version 1 of our technology that we're just not focusing on recovering because we want to get to market as quickly as possible. And we'll also produce salt, so simple road salt, NaCl, from our process. And that we're hoping it can actually be used as road salt, especially if we're in colder climates deploying. And then those are the only solid outputs, with the exception of in e-waste, there'll be waste plastics. So DEScycle, we're not a plastics recycling company, but the major difference between plastics in DES is DES doesn't interact with plastics. So the plastics travel through the system and then can be sent for onward recycling, disposal, using aggregates, whatever you are, depending on your flavor of plastic you're dealing with. In smelting, everything's burned in a furnace before it goes into the smelter, plastic's destroyed. And even in acids, you have an interaction going on called plastic acidification, where your acids are absorbing into the plastics, making this big gloopy mess. And then you have to incinerate or destroy the plastic. So we're actually one of the only processes globally which will preserve plastics from e-waste going through. So for suppliers of legacy products and e-waste, we can offer a solution that doesn't destroy any of these key components. through that recycling process.
I think this sounds really exciting, Fred. I think you guys are really onto something. I mean, you've got strategic investment. You've got some serious science behind it. Obviously, when we can, we would like to get a hold of some peer-reviewed material that can be translated to more lay or more common understanding content, which is one of the many things we do. But it sounds extremely exciting. And, it sounds like if this takes off, you're going to become one of our new very wealthy friends.
Hope to be. Hope to be. We're realistic about the journey ahead of us, right? We know there's risks left. We know there's scale risk, commercial risk. We're eyes wide open in terms of the problems we have to solve and how to make this business a success. So, it's not what we've seen in the market as well. And you guys have seen this, a lot of the big names who make similar mistakes, it seems. And a lot of it is trying to scale too quickly. It's really, really kind of appetizing to go from, let's say, a small demonstration facility up to something that will be doing $1 billion in revenue year one. But what we've seen over the past few years is so many CapEx blowouts. And with everything that's going on in the world, multiple companies have failed and gone under. You would have seen, I'm sure, Ascend filed for bankruptcy very recently in the US, which is a great shame. There's multiple reasons for all of these, but again, something that our business model protects us about, because we're not going after that $1 billion CapEx build. Our scaling strategy is small scale, repeatable infrastructure. The risk, absolutely lower.
And I was just going to say, the having strategic investors, part of the problem is, the financialization of our supply chains, manufacturing, engineering. If things are driven by, financial concerns first and foremost, you always, of course, finance is key and profitability. But if it's not an engineered chemistry, engineering driven process ethos, you're going to have problems. Because there is a natural growth trajectory. Venture capital is known to say, we want you to be grow at 5,000% within year 5. But sometimes the science just works at a different pace. And so you need to have the investors that understand that and can work with the business people and the chemists and the engineers to scale it up in a way that it can be successful. So I totally agree with you, and it makes a lot of sense what you're saying. Dustin, I know we're coming to the end, but I think this is a very exciting breakthrough, and I think we can get more attention on this.
Absolutely. So I have just a couple questions. Some of them we've kind of addressed a little bit, but with your strategic investors, you've got quite the diverse set of them that have come in to help DECycle. How do you manage a cap table where all these investors have their own specialized interests in what they might want you to do? How do you manage those expectations?
Yeah. So from a broader scale, I think any company who's raising serious amounts from venture and private equity is always competing with differing interests from different investor groups, right? Everyone's got their own story. For us, the strategic investors have been incredibly helpful. So Mitsubishi in Japan, also one of the world's largest metal trading houses. That was their original investment thesis. We've recently announced a new partnership with them to partner to deploy the technology itself in the Japanese market as well. I couldn't think of anyone better to launch in the Japanese market. But what that's done is put competitive tension on the process of, okay, where are we building first? So we have a joint venture here in the UK, which is still definitely our plan to deploy in the UK first. But we have lots of traction, partners, and pull from the US and Europe. So it's one of these things where, as the commercial officer in the business, I wish we were almost like 2-3 years ahead. So we had this repeatable infrastructure. So we were like, hey, let's go build 5 of these things right now. But we know that journey is we have to nail this demo plant. We have to nail that first build to get to that point where we've got repeatable infrastructure to where we can move out. We're also quite lucky in the fact that it's slightly different in terms of Cisco are really looking for that reverse supply chain solution. So supplying hardware to a sustainable technology and traceable technology like DEScycle, so they can capture those sustainability and traceability benefits. Whereas Mitsubishi are all on the metal offtake side, so on the back end of the process, and on that co-deployment. So although they're pulling from, let's say, two different geographies, they're both global companies, which helps.
Great. So, and speaking of deploying in the UK first, you've been vocal online about essentially this idea that Britain can innovate, but they fail to deploy or scale. How is DEScycle going to break that, they would say, tradition, and allow you guys to scale?
Yeah, well, as a proud Brit, I'm ashamed to say it is a bit of a tradition here. We've launched some of the, world-leading technologies over the years and industries, and we've lost them. Quite frankly, we lose them, and you've done your homework, Dustin, on reading what I've been spouting off about. And the UK
Well,
really
Fred, you lost a whole empire, for goodness sake.
Yeah. We're
What do you expect?
bit of a streak here, but particularly with industry, right? Particularly with industry. So with this fantastic, innovative environment, the university, the academia, the science, amazing. You get to about our stage, around TRL7, where you go from R&D capital to infrastructure capital, and there's a massive funding gap. And this is exactly what we're coming up on at DEScycle now. It's how do you build the very first of a kind infrastructure plant? So these are the versions that are probably going to be a bit ugly. So the classic one that everyone uses is the kind of evolution of the SpaceX rockets, where you have that first one where you've got all these pipes all over the place. Second one looks a bit more refined. And then by version 3, it's something super sleek and beautiful. And it was like, oh, wow. But that's the evolution of almost any technology. So what we have in the UK is both a public financial gap and a private investor gap in funding those type of projects. The US, really, really good at funding those. US investors understand that risk and they like taking it because they know what it unlocks. It's really bridging the demo scale and large scale industrial infrastructure. It's the bridge between that. So jumping that bridge is going to be a big, big challenge, particularly here in the UK. We have got quite good political and government support to deploy domestic critical metals recovery technologies here in the UK, but the proof's going to be in the pudding. And we are getting pulled by people like Mitsubishi, people like Cisco to deploy in these markets, which are more used to funding these first of a kind builds.
Yeah, just quickly on that note, it's interesting though, because London is one of the major financial innovators of the world, but I agree with you to that point. That's not an area that is in high demand in London.
It's appetite, Daniel. It's really risk appetite. If I had a de-risk technology that had been operating for 2 years and I was ready to build more of them, so I have that repeatable infrastructure, I could take a walk from where I am in my flat and have the thing financed very quickly.
Yeah.
But that's because it's low at that point.
Yeah.
It's high. The UK is just more conservative. So.
Yeah. Makes sense.
Absolutely. So Fred, thanks for being on the show and sharing all the kind of exciting things that DEScycle is working on and what it will mean for the e-waste recovery, metal recovery from that, because you can only get so much out of the ground, and obviously mining takes a lot more time and effort. So we are very interested in your success and hope that you guys do well, and we would love to have you back on the show in the future to get an update with you on how the demo plant went and the scale of it. So that'd be great.
Yeah, that's fantastic. And if you guys are ever over in the UK, you like proof in the pudding, so maybe you can come up to our demo facility and we can show you exactly what's going on.
Absolutely, that'd be fun. So Fred, for those that would be interested in connecting with you, learning more, or even being a part of what DEScycle is doing, where should they go? Yeah,
so go to the DEScycle website. Contact details are on there. Also LinkedIn, we're quite active on, so you can reach out to us directly. We're very happy to speak to potential partners, hires, collaborators, and just people who want to talk critical minerals.
Absolutely. Awesome. Fred, thanks so much again, and we'll talk to you soon.
Fantastic. Cheers both. Thanks for your time.
Thank you.